Good morning, everyone. Thank you very much for joining in the class. Today is our third lecture, and today we'll discuss about another acid-base theory and also about the pH. Okay. So, can anyone tell me what we discussed in our last class? Any more? Okay. So, according to the Arrhenius theory, which compounds are acids? Okay, that means all the compounds having hydrogen will be acid. Okay, great. And what is bronze state Lowry acid? Which compounds are bronze state Lowry acid? Okay, hydrogen ion or proton donor, right? Okay, and the compounds that accept the proton are base, right? Okay, so can anyone define which one is the acid here and which one is the base here in this reaction? This equation. Oh, sorry. I have to set the screen. Yes. Sorry, yes. Okay. From this reaction, can anyone define which one is the acid and which one is the base? Okay, why? Is this compound is donating hydrogen ion or proton? Then how can you define this one as the acid? Oh, okay, you studied it intermediate. Okay. Okay, sharing the electron. Okay. Okay, that means from the previous two theories we can't define this one as acid, right? But we know that ammonia is the base, right? According to the last theory, that is Bronsted-Lowry theory. Am I right or wrong? Okay, so as this is the base, then it must be the acid, but we can't define it, right? Based on the previous two theories. Okay, so to avoid such complication, another scientist worked and he tried to resolve this issue. So according to the Lewis, acid accepts a pair of electron and base donates a pair of electron. Clear? Now the concept comes to the electron. So what is electron? Do you know what is electron? Sanjida Hossain? Okay, where electron present? Okay, in atom. Okay. Okay, so electron charge is negative. Okay, so if a compound accept electron, what you will call them? If a compound accept a pair of electron, we will call them acid. Okay. Okay, and if the compound donating the electron, then we will call them base. Clear? Okay, so now think about this. Here, which one is donating the electron and which one is accepting the electron? Okay, and boron trifluoride is accepting the electron, right? So then this one is the base, right? Okay, I said wrong and you said yes. So that means you didn't understand it. Okay, so as it is accepting the electron pair, that's why it is acid. Okay, clear now? Samiha? Okay, okay. Arnav, explain karo to why this one is the acid and this one is the base. বোরন ট্রাইফ্লোরাইডটা সেই কারণে বেজ হলো আর কি, রাইট? আচ্ছা, মাত্র একটা জিনিস শিখালাম, তুমি আবার উল্টাপাল্টা বলতেছো। তাহলে তুমি কি শিখলা বলো? তানভীর, ক্যান ইউ এক্সপ্লেন? তানভীর? Okay, you need more understanding. Okay, okay, then who can explain? Jeba Fariha? Okay, good. Okay, so some of you are confused till now. Okay, so look at the whiteboard. According to the Lewis theory, acid will accept electron. I don't know why it is not working. Okay, acid will accept the electron. Okay, and base base will donate electron. Okay, acid will accept and base will donate electron. Clear? For mnemonics, this one you can use. Okay, acid A accept A. Okay, clear? Okay, so now comes to the ammonia structure. Do you know the atomic number of nitrogen? Nitrogen atomic number 14. Okay, Okay, so 14 and 7, which one will be right? Okay, 7. So that means there will be 7 electrons, right? Okay, then if we look at the electronic configuration, 1s2, 2s2, 2p. How many 2p? Okay, 2p3. Okay, that means there is 3 electrons. Okay, so now these 3 electrons will bond with 3 hydrogen. Okay, these 3 electrons, and here 2 electrons present, there's 2 electrons here. Okay, these electrons we can call lone pair electron. Clear? Lone pair. Lone কেন? কারণ as they are separate. Okay, these electrons are not in any chemical bonding. Okay, and as there is 2 electrons here, that's why pair, lone pair. Clear? Okay, so ammonia can donate these electrons. Okay, and bf3 can accept these electrons. Okay, so as it is accepting the electron, that's why it is acid, and this one is donating the electron, that's why it is base. Clear now? Any confusion? Okay, so what is Lewis acid? Zerinthus name? Okay, electron গ্রহণ করবে. Okay, and what are base? It's simple, right? It's not that much difficult. Okay, দান করবে. Okay, okay, good. Okay, so now uh, Afsana meme, which one is acid here and which one is the base here and why? Okay, and this one is the base, right? Okay, so in the previous two theories, we also discussed that hydrogen ion or proton donating compounds are acid, right? Okay, so that means this theory will cover previous two theories as well. Clear? Okay, so now what we can summarize from the three theories? Asha Tasnim Ali. Okay, could you please tell the summary of the acid and base according to three theories? But you can't explain. Okay, why you can't explain? Just try, no problem at all. Just try. আচ্ছা, তুমি যদি ট্রাই নাই করো তাহলে কি তুমি শিখবে এক্সপ্লেন করা? ওকে ওকে, নেক্সট ক্লাস. ওকে, ফাইকা. ওকে, হু ক্যান এক্সপ্লেন? ওকে ওকে, এক্সপ্লেন. ওকে, Okay, next, who can explain? Okay, try. Okay, so now is it clear to all? Nazif, can you explain again? Nazif, can you explain it again? Which is the acid, which is the base, according to three theories? Okay, so according to the Arrhenius concept, we know that okay, বাংলায় বলতে হবে রাইট আচ্ছা আরহেনিয়াসের মতে যে কম্পাউন্ডগুলা জলীয় দ্রবণে হাইড্রোজেন আয়ন বা প্রোটন দেয় তারা অ্যাসিড আর যে কম্পাউন্ডগুলো জলীয় দ্রবণে হাইড্রোক্সিল আয়ন দেয় তারা অ্যাসিড ক্লিয়ার সরি ক্ষার ক্ষার বা বেস ওকে আচ্ছা ব্রোনস্টেড লাউরি কনসেপ্ট অনুসারে যে কম্পাউন্ডগুলো জলীয় দ্রবণে হাইড্রোজেন আয়ন দিবে বা দান করবে তারা অ্যাসিড এবং যে কম্পাউন্ডগুলো জলীয় দ্রবণ না সরি যে কোনো দ্রবণ হতে পারে ওকে যে কোনো দ্রবণে বা যে কোনো কন্ডিশনে যদি হাইড্রোজেন আয়ন দেয় তাহলে তারা অ্যাসিড আর যদি হাইড্রোজেন আয়ন যে কম্পাউন্ডগুলো অ্যাকসেপ্ট করবে তারা হলো বেস ক্লিয়ার আচ্ছা লুইস থিওরি মতে যে কম্পাউন্ডগুলো ইলেকট্রন দান করবে তারা হলো বেস ইলেকট্রন ডোনেট যারা করবে তারা বেস তার মানে একটা ইনভার্স হচ্ছে ওকে মনে রাখার জন্য জাস্ট আচ্ছা আর যে কম্পাউন্ডগুলো জলীয় দ্রবণ যে কোনো দ্রবণে ইলেকট্রন পেয়ার গ্রহণ করবে তারা হলো অ্যাসিড ক্লিয়ার না ঐশী okay now who can explain this question Farhad Zarin can you explain this okay Nobi Tripti okay Tripti can you explain it আচ্ছা, হাইড্রোজেন আয়ন কি ইলেকট্রন পেয়ার দান করবে নাকি অ্যাকসেপ্ট করবে, কোনটা? ওকে, অ্যাকসেপ্ট করবে। ওকে, ওকে অর্ণব, ইউ ক্যান ট্রাই অলসো।
স্যার হাইড্রোজেন আয়ন যখন দান করবে মানে ডোন ক্লাউডি আয়নিক অ্যাসোসিয়েট করে দেবে
কি যে বলতেছে আমি কিছু বুঝতেছি না, হাইড্রোজেন আয়ন দান করলে তো সে বেজ কেন হবে? আচ্ছা, কোশ্চেনে বলা হয়েছে যে আর হাইড্রোজেন আয়ন ডোনর্স অলসো ইলেকট্রন পেয়ার অ্যাকসেপ্টর, তার মানে হলো যারা হাইড্রোজেন আয়ন দান করতেছে তারা কি ইলেকট্রন পেয়ার অ্যাকসেপ্টর কিনা। ক্লিয়ার? কোশ্চেন ক্লিয়ার? The question is asking you that are the hydrogen ion donors are also electron pair acceptor. Clear question? Okay, now you can try. Okay. ওকে, ওকে, আচ্ছা আচ্ছা আচ্ছা, বুঝতে পারছি। আচ্ছা, ওকে, তোমার কনসেপ্ট বুঝতে পারছি আমি। ওকে, হু ক্যান এক্সপ্লেন ক্লিয়ারলি দিস ইস্যু?
Sir, can I try?
ওকে, শিওর।
Sir, the question asks whether hydrogen ion donor should correspond to interaction with base. Because according to the Lawless theory, hydrogen donors are acid and according to Lewis theory, electron pair are base. So therefore, all free hydrogen ions are electron donors.
ওকে, ইজ ইট ক্লিয়ার নাও?
Yes, sir.
এনি কনফিউশন?
স্যার অন স্যার ইন দিস কেস which compound will justify the condition
হুইচ ওয়ান?
মানে এখানে যে রিজনিংটা বলা হয়েছে হাইড্রোজেন আয়ন ডোনার হবে ইলেকট্রন পেয়ার অ্যাকসেপ্টর যদি এক্সাম্পল নিতে চাই তাহলে
ওকে, তুমি যে কোনো রিয়েকশন দিতে পারো, সবগুলোই তো সেম কন্ডিশন মেনটেন করবে। আচ্ছা, ওকে, সো suppose you don't know a condition. Okay, say you don't know, okay, how I will explain whether it is acid or base. Okay, suppose you don't know something. Okay, so then start from the scratch. Okay, so start from the simple thing. HCl is acid, right? Am I right or wrong?
রাইট স্যার
Yes, sir.
Okay, so no matter which theory we are like learning, all the theory will define it as acid, right? Clear? Okay, this is universal thing, right? That hydrochloric acid is an acid, right? Okay, and if you look sodium hydroxide, this one is the base, right? Sodium hydroxide.
ইয়েস স্যার
Okay, so no matter which theory we are learning, this one will be the base. Always this one will be base. Clear? Okay, some of you are so late. Why? Okay, so do you know what is pH? Ahmed, why so late? Oh, okay. Okay. What is pH? Do you know what is pH? Okay, great. Okay. So this topic is very important because we will need this information in our future works. Okay. No matter where we will work, like in the industry or in the research lab, we will need this information. Clear? Okay. So for determination of the pH, we can use the pH scale. So pH scale, we can see the ranges, right? From 0 to 14. Okay. So from the starting point to like 6.9, it is like acid, and from here to from like 7.1 to say 14, it is like baseline. Okay, it is for base. Clear? Okay, and 7 is the neutral pH. Clear? Okay, so now if we wish to determine the pH, there is two different procedure. First of all, the qualitative procedure, and then the quantitative procedure. Okay, so qualitative means that it will give us just an idea whether the solution is acid or base or neutral. Okay, clear? It will give us just the idea, but the quantitative test will give us the range of the pH as well, whether it is like range of the pH is 3 or 4, or it is like 7 or 11, like that. Clear? Okay, so do you know what is indicator?
Yes, sir. Can you spell it?
Okay, so from the name we can see that indicator, that means it will indicate something, right? Okay, so what it will indicate? It will indicate whether a compound is acid, base or neutral. Clear?
Yes, sir.
Okay, so there are many different indicators that we can use to determine the acid, base or neutral compounds. Okay. Okay, so think about the litmus. Litmus comes from the plant, and this litmus is widely used to determine the acid and bases. So in the solution, the acid solution, if you dissolve the litmus in an acid solution, it will be red. Clear? And in the basic solution, litmus will be blue. It's pretty simple things, but when we ask in the viva, you are confused. Okay, so don't memorize both this line, just memorize one. Okay, clear? So acid red or basic blue. Okay, so then you can determine the other is the opposite. Okay, clear? Okay, so from here we can see that basic there is B and blue there is B. Okay, clear? You can use this mnemonics as well. Okay, so suppose you are dissolving a litmus into a solution. Okay, and it is neither red color, it is not appearing red or blue color, then what you will say?
Neutral.
Okay, neutral then. Okay. Okay, so there is another indicator, that is phenolphthalein. Okay, So in the acidic solution, phenolphthalein is indicates no color. There is no color of the phenolphthalein, but in the basic solution, it's pink to like light pink to dark pink color. Okay, clear? Okay, so next the process is quantitative procedure. So this process is widely used in the laboratory. Okay, so why this process is widely used? Because it is very accurate and it will indicate your pH range very accurately. Okay, and it can be used in the solution and it is very easier to use. Okay, clear?
Yes, sir.
Okay, so if I ask you, okay, how can you determine the exact pH of a solution, then what you will do? Okay, pH meter, clear? Okay, do you know how this pH meter works? Okay, you don't know. Okay, so here there is a machine. This machine will show you the reading. You can see the display here. So in the display you can see the reading. So reading will reflect the pH of the solution. Clear? Okay, and there is a probe, and this probe actually dissolve in the solution, and through this probe the measurements actually comes to the machine. Clear? And then it process the information and then it will display the information. Clear?
Yes, sir.
Okay, so before,
Can you repeat again how did it work? My network was.
okay, so in the pH meter there is like a machine and a probe. Okay, so this probe actually dissolve in the solution. Okay, and it takes information from the solution and it transfer it to the machine, and the machine then process this information and it shows the information in the display board. Clear?
Yes, sir.
Okay, so before measuring a pH of a solution we need to calibrate it. Okay, what do we need to do? We need to calibrate it. Okay, calibration. Clear?
Yes.
Okay, what is calibration? Okay, next point. Okay, so in the lab or industry we need to prepare a solution of like a certain pH. Okay, so it may be like pH 7.4, pH maybe 8, pH maybe 10, maybe 1 2. Okay, so that means we know that the solution pH will be 7 or 8 or 9. Clear? Is it clear? Okay, for example, if you prepare the media for cell culture, the pH will be 7.4. Okay, so that means we have to convert the media pH 7.4. Clear? So if it is like 6, then we need to convert it 7.4. If it is like 10, we need to convert it this. Clear? Okay, okay, so now this one is our target pH, right?
Yes, sir.
Okay, so to achieve our target pH we need to calibrate the machine based on our target. Okay, so if it is 7, then we can calibrate the machine with pH like say 7 and 10. Okay, so why we will use 7 and 10? There may be like other calibration solution, maybe like 4. Okay, maybe 2. Clear? So why we will pick up 7 and 10 in this case? Because we have to select the calibration solution accordingly our target. Okay, that means the target will be in between these two pH. Clear? In between. Is it clear now? If your target solution pH is like 5, so then you will select this one and this one as your calibrating agent. Clear? Is it clear now, this point? Okay, so now what you will do, you will suppose this is your pH probe. Okay, this is your probe. So what you will do, you will calibrate it first using say pH 10. Okay, so calibration means that you will teach this machine that okay, this solution is pH 10. Okay, so if you find similar type of solution, then you will show reading 10. Clear? Is it clear? Okay, so this calibration means it will actually teach this probe. Okay, it will teach it. Okay, what it will teach, it will teach that okay, if you find solution something like that, then you will show reading of pH 10. Clear? না আচ্ছা আমি আবার রিপিট করতেছি calibrating solution. Okay, so we know that this solution pH is 10. Okay, because this is the standard solution. Okay, we know that the pH of this solution is 10. Clear? Okay, now we will use this solution to calibrate the machine. Okay, so actually this solution will teach this probe that if you find something like the similar concentration, you will show reading 10. Clear now? আচ্ছা আমি যদি একদম সিম্পলি বলি, সাপোজ ইউ আর টিচিং এ বয় ওকে হোয়াট ইজ ম্যাঙ্গো অ্যান্ড হোয়াট ইজ অরেঞ্জ. ওকে, so you will show the a boy a mango and teach him okay, if you see something like this is mango. Okay, okay, so like this, so this solution will teach this pH probe that okay, if you find concentration something like this, you will show the pH range 10. Clear? Okay, so after teaching it, what we do, we wash it, we wash the probe, and again we will put the probe into pH 7 solution. Okay, pH 7 solution. Clear? Okay, so now the machine will show pH 7. Okay, clear? After teaching it will show pH 7. Okay, so now it knows that how can it determine the pH. Okay, so now if you show your target solution, then if it shows like 10, then you will try to add the acids. Okay, so if you try to add the acids, the pH will decrease, right, gradually. Okay, then when it reaches to the 7.4, then you will stop. Okay, okay, so suppose your target solution pH is 7.4. Okay, then where you can go, you can, if your solution pH is 7.35, then it is okay. Okay, we allow up to 0.05 fractionation. Okay, clear? Not more than that. Okay, so if it is like 7.45 up to 7.45, then it is okay as well. If it is more than that, 46, then we will not allow it. Okay, okay, so same here as well. After you teaching the pH probe, okay, your calibration is done. Teaching means the calibration is done. Okay, now if you're putting the pH 10 solution again, okay, if it shows, sorry, pH 7 solution again, if it shows pH like 6.99, then it is okay. If it is like 6.95, up to this point is okay. If it shows less than this, like say 94, then your machine is not okay. Clear? And if it shows 7.05, then your machine is okay, but if it shows 6, then your machine is not okay. Clear?
No, sir, 0.05 portion of the test.
Yes, 0.05 plus minus 0.05 plus minus 0.05. Okay, clear now?
Yes.
Basically, probe is acting as per the solution.
Yes, probe is acting as per as the solution. Any question, any confusion from here? Okay, no, good. Okay. Okay, so like litmus, there is another paper, that is hydrogen paper, that we can also use to determine the pH, but unlike the litmus, it will show the quantitative measurement. Okay, clear? So hydrogen paper in different pH, it will show different color. So based on the color code, we will understand the pH of the solution. Clear? For example, if the solution pH is 1, around 1, then it will show this color. Okay. If the pH solution is 6, solution pH is 6, then it will show this color. Clear?
Yes, sir.
If the solution
Yes, sir.
if the solution pH is like 13, so then it will show this color like this. It will work.
Sir, do we have to remember these colors?
No, you don't have to remember this color code. You just understand this, okay? Because this color code will be given with your hydrogen paper, so you don't need to memorize this color code. Okay, so through the hydrogen paper we can get an idea, okay, that the solution pH range, we can get the idea, okay, not the exact pH. Clear what I mean? Suppose the hydrogen paper color is this one, okay, clear? Suppose this one, okay. So if it colors like this, then the pH may be like say zero point 0.9, it may be 1.1, it may be 1.2, okay. It will give you an idea, it is around 1, okay, around 1, but not the exact idea which pH it is now. Clear? Is it clear to all? Any confusion? Okay, sure. Okay, so hydrogen paper, actually you can see here that if it the pH range is like this, like 1, around 1, it will show this color. So that means it may be like 0.9, it may be 1.1, it may be like 1.2, like this, okay. So around this pH it will show the same color, okay. It may be like 0.08 as well, okay. So that means you are not getting the exact pH idea, okay, clear? It is showing the about range, but not the exact pH. Exact pH means it may be like exact pH may be like 1.05, it may be 1.10, okay. It will not show it. Okay, so now we'll see the summary, okay. Shital, what is hydronium ion?
Sir, no hydrogen ion. Hydrogen ion is conjugate acid.
Okay, great. Maliha, what is conjugate acid?
Sir, that is on the base brings the hydrogen ion.
Okay, can you give one example? Could you give one example?
Sorry, sir. That's all.
Okay. Oishi? What is conjugate acid? Okay, ammonia is conjugate acid.
Ammonium.
Ammonium, okay. Okay, good, okay. Nazifa, what is conjugate base? Okay, good, okay. Can you give one example? Hydroxyl is the conjugate base. Okay. Hydroxyl is acid. How the hydroxyl is conjugate base? Okay, if the hydroxyl is conjugate base, that means this hydroxyl must have to come from an acid, right? Okay, does hydroxyl come from the acid? Okay, so can you give me one example of it? Yes, it may come from the acid as well. Okay, can you give me one example? Okay, does sodium hydroxide acid? Okay, no, sodium hydroxide is base, right? Okay. Noriza?
Vodka.
Okay, what is conjugate base?
Sir, conjugate base is when an acid donates a hydrogen ion to its reactive on the bonding group.
Okay. Can you give one example?
Sir, when water becomes a hydroxide ion, that is conjugate base.
Okay, so we know that water is amphoteric, means it can act as acid or base, right?
Both acid and base.
Okay. Okay, so when water is donating the proton, it will produce hydroxyl, right? So this one is the conjugate base. Okay, conjugate base. Clear? Okay, so if we look at HCl, then Cl minus is the conjugate base. Clear? Okay. Usha, what is conjugate acid base pair?
Conjugate acid base pair is two substances base and pair similar.
Okay.
Continue.
Yes, yes, sure. Continue.
So in the reaction of ammonium ammonium ion occurs here as conjugate this is the conjugate base of ammonium. So conjugate acid.
I feel we are confused till now because ammonium is the acid, right? Ammonium because it has power to donate a proton now, right? Okay. Tripti, can you give us one example of conjugate acid base pair?
Sir, the it is EBH2 bond.
Okay, reaction mononia. Okay.
Sir,
Yes.
sorry to interrupt. Actually, na, if I'm not wrong, actually I'm bit confused about that. Like, এখানে কি মানে অ্যাসিড প্রোটনটাকে ডোনেট করে অ্যান্ড দেন জাস্ট বেসে কনভার্ট হয়ে যায়, রাইট? অ্যান্ড বেস যখন প্রোটন অ্যাকসেপ্ট করে দেন এটা অ্যাসিডে ফর্ম নেয়।
Okay, we are going to the reaction. Okay, to explain it clearly. Okay. Okay, this reaction we can explain clearly. So now say, explain this reaction.
So here already the acid product which was found around acid which were ammonium ion and HCl ammonia.
Okay, good.
So water and acid is acid H2O and HCl which was ion is soda which is water is acid.
Okay, so according to the Bronsted theory, we know that acid will donate the proton and base will accept the proton, right?
রাইট স্যার।
Okay, so when the acid donate the proton, the base actually accept the proton, right? So this is the base, it accept the proton. Okay, so now these base can donate proton in the reverse reaction, right? So when we go reverse, what we'll get from ammonium, we will get the ammonia, right?
রাইট।
Okay, so that means it is donating the proton. So if it donate the proton, that means it's the acid, right? So actually this acid, where from it's come? It actually comes from the base. Okay, base ammonia. Okay, so that's why it is the conjugate acid of ammonia base. Clear?
ইয়েস স্যার।
Okay, then what is amphoteric substance? Shathi Saha,
স্যার,
what is amphoteric substance?
স্যার,
You forget. Okay, Sakib Khan.
Oh, sorry, sir. It's have both acid and base. Sir, acid এবং ক্ষার দুটোই।
Example.
স্যার, সোডিয়াম হাইড্রোক্সাইড।
আচ্ছা, সোডিয়াম হাইড্রোক্সাইডের মধ্যে অ্যাসিড বেস দুইটাই থাকে। আচ্ছা, ওকে, গুড, বুঝতে পারলাম। আচ্ছা আচ্ছা, তোমার কনসেপ্টটা কি রাইট ও রং কিনা সবাই সাথে কথা বলে, তাহলে সবাই কি অ্যাগ্রি করতেছে দিস ইজ রাইট?
স্যার ওয়াটার।
ওকে, সোডিয়াম হাইড্রোক্সাইড অ্যাম্ফোটেরিক, ইজ ইট রাইট ও রং?
রং স্যার।
ওকে,
It's just the base.
okay, sodium hydroxide is only the base. Okay, so what is amphoteric substance?
Which work both acid and base.
Okay, okay, so which compounds can act as acid and base both?
Water.
Okay, water. Okay, okay, water, yes, water is the amphoteric substance because it can act as acid or base together. Okay, either acid or base. Okay, Shafi, clear now?
Yes, sir.
Okay, to clarify more, you can see here that water is, it can donate this one and this one as well, right? Clear now? Okay, Sakib Khan. Okay, Mohit. Tawhid or Mohit.
Ji sir.
Okay, what is Lewis acid?
So Lewis acid are the one that can accept a pair of electrons from the base.
Okay, can you give me one example?
Boron trifluoride.
Okay, it is not boron, it is boron trifluoride. Okay, boron trifluoride. Clear? Okay, thank you. Taskia Rahman, what is Lewis base? Okay, donate a pair of electron. Okay, which compound can donate pair of electron? Okay, you forget the name. Okay, ammonia. Okay, good. Okay. Do you have any question from this lecture? We have completed our lecture 3. So, do you have any question?
Sir, could you please show me the reaction when water is acting as a base compound, basic compound?
Okay, water is acting as a basic compound. Okay. Okay, who can explain this? Any one of you?
Sir, questionটা আবার একটু রিপিট করা যাবে?
Okay, we know that water is amphoteric, right? So that means water can act as acid or base, right? So Najif is asking an equation where water is base. Okay. না স্ক্রিনশট তো করা হয় না, তুমি বলো।
Sir, if water reacts with an acid type of acid, then it will accept electrons from the base upon having activated the base.
Okay. Okay, that means it must have to react with a acid, right?
Yes, sir.
Okay, so if it react with
Yes, sir,
acid,
understood.
okay. So if you understood it now, you can say, okay, you will tell the reaction. Then, sorry. Yes, Tanvir, you can leave. Okay, sure.